Imagine discovering something in the deepest, darkest parts of the ocean that completely flips our understanding of how life sustains itself. Oxygen, the very essence of life, is being produced in places where it shouldn't exist, miles beneath the ocean's surface, in total darkness. But here's where it gets controversial. This groundbreaking discovery challenges everything we thought we knew about how oxygen is created on Earth. Could this change how we view the origins of complex life? Let's dive in. In the abyssal plains of the Pacific Ocean, where sunlight never reaches and temperatures hover just above freezing, a team of scientists led by Professor Andrew Sweetman from the Scottish Association for Marine Science, SAMS, stumbled upon something extraordinary. At depths of around 13,000 feet, 4,000 meters, they found evidence of oxygen production without any sunlight or photosynthesis. This dark oxygen defies conventional wisdom, which teaches us that oxygen is primarily generated by photosynthetic organisms like plants and algae near the ocean's surface. But how is this even possible? The researchers focused on an area called the Clarion-Clipperton Zone, CCZ, a region littered with potato-sized polymetallic nodules, hard, layered balls rich in manganese, iron oxides, and traces of nickel, copper, and cobalt. These nodules, resting on the seafloor, have long been eyed for deep-sea mining. But their role in producing oxygen in the dark? That's entirely new. Using a robotic lander equipped with clear, box-shaped chambers, the team enclosed small microecosystems of sediment, water, and nodules. Instruments called optodes measured dissolved oxygen levels every few seconds for nearly 2 days. The results were astonishing. Oxygen levels started at around 185 micromoles per liter and skyrocketed to over 819 micromoles per liter in some chambers, more than triple the initial amount. And this is the part most people miss. The oxygen production rates were higher than consumption rates, meaning the seafloor was actively generating oxygen. To rule out errors, the team double-checked their findings using the Winkler method, a classic chemical test. They also accounted for potential glitches like air bubbles, natural radiation, and even the lander's impact on the sediment. Every test confirmed the same result. Oxygen was being produced in the dark, likely through reactions on the nodule's surfaces. But why does this matter? This discovery not only expands our understanding of Earth's oxygen cycle, but also raises questions about the early evolution of life. If metal oxide surfaces can catalyze oxygen release in the dark today, similar processes might have occurred in the ancient ocean, shaping the planet's atmosphere and the development of complex life. And here's the kicker. This process could be disrupted by deep-sea mining, which would disturb the seafloor and potentially alter oxygen production. So, what do you think? Is this a game-changer for our understanding of life's origins, or just a fascinating quirk of deep-sea chemistry? Could deep-sea mining inadvertently harm processes we're only beginning to understand? Let's spark a conversation in the comments. Your thoughts could shape how we approach this discovery.